Good morning. Video number 2. Today we're going to talk about graphing a piecewise function. And we're going to do 3 of them together. You can find other videos online to do this if you're looking for some more explanation. In terms of graph paper, I will make sure to post some graph paper on Classroom so that if you have a printer at home, you can print it. If you don't have a printer, then just very carefully with a ruler or some kind of straight edge, just draw the graphs on your notebook paper. So, typically the graph of a piecewise function is discontinuous. In other words, it has one or more gaps or breaks. So what that means is if I'm drawing a piecewise function, many times I will have to lift my pencil. I won't be able to graph the entire thing without ever lifting my pencil. I'll have to jump from one piece to another. Sometimes I don't have to lift my pencil. Sometimes I can do it all in one drawing. Now, I teach this in a really silly way. I teach graphing piecewise functions as having yards, as buying property. And the fences are determined by where the constraints are. So in this first case, right here, I know that I have one piece of this graph when x is less than 0, and the other piece when x is greater than or equal to 0. So my fence, meaning where I change from one function to the other, happens at x equals 0. So what I always do is I draw my fence. Now I hope you can see that yellow. Remember, the line x equals 0 is just the y-axis. Now again, this is totally silly, but students in the past seem to understand it when I'm silly like this. I'm going to call this Mr. Red. Now Mr. Red lives in the yard where x is less than 0. So let's talk about where is his yard. Well, where is x less than 0? Well, all this over here, all this stuff over here is where x is less than 0, because here's x equal -1, -2, -3. So that's where x is less than 0. So Mr. Red's yard is right here. Now, let's call this one Mr. Green. Now, Mr. Green lives in the yard where x is greater than 0 or equal to 0. Let's just talk about the greater than 0. The greater than 0 part is over here because this is where x is 1, x is 2, x is 3, and those numbers are bigger than 0. So this is the yard where Mr. Green lives. Now, who owns the fence? Well, the person who owns the fence is the person that has the or equal to part. In this case, Mr. Green owns the fence because not only is his greater than 0, his is also equal to 0. So Mr. Green is the only one who can touch that fence. Now, for anybody but Mr. Green, that fence is an electric fence. So if Mr. Red touches that fence, he's going to get shocked. He can't touch that fence. So we'll talk about in a minute what that looks like on the graph. So let's talk about graphing Mr. Red. Now you guys know, remember I'm having trouble with my smartboard. It's not showing about the farthest right foot. So I'm having to be real careful about where I write things. Remember, y-intercept, slope. So for Mr. Red, y-intercept is 2, and the slope is -1. The -1 is sitting right there. So let's do the y-intercept first. The y-intercept means on the y-axis I go up to 2 and make a point. But wait a minute, I got a problem with that. The problem with that is that that's on the fence. He can't touch the fence because he doesn't own it, so he's going to get shocked if he touches that fence. So what I'm going to do is I'm going to put an open circle there, and that's going to mean There really should be a point there, but he can't touch it because he doesn't own it. Now, let's do the slope. The slope is -1. Now remember, to do a slope of -1, I can go up 1 and left 1, like this, up 1 and left 1, or I could go down 1 and right 1 over here. But wait a minute, if I go over here, that's not Mr. Red's yard. That's Mr. Green's yard. He is trespassing. So he cannot be graphed over here. So Mr. Red, that's what Mr. Red's house looks like. Looks just like that. It's the line -x + 2 only graphed in his yard, and he does not own the fence. Now let's talk about what Mr. Green's looks like. Mr. Green is 2x + 1. Well, 2x + 1 means a y-intercept of 1. Now he can touch the fence because he owns it. Slope of 2 is up 2, right 1, up 2, right 1. So Mr. Green looks like this. Now remember, I could go down 2, left 1, down 2, left 1, but that's in Mr. Red's yard. He's trespassing. He cannot go there. Ladies and gentlemen, you just graphed a piecewise function. Da, 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 da. Now, let's go to the second one. We're going to do three of them. We're going to do that one last. We'll go down to this one. Okay, so let's decide where the fence is. Well, the fence is at x = 1. So I'm going to go and draw a dotted line where x = 1. Now I need you to understand that dotted line is not really part of the graph, but it's just a visual reminder for us to know where the fence is, where the boundary is between those two pieces. Okay, so let's go with Mr. Red and Mr. Green again. Here's Mr. Red. His equation is 1/2 x + 3/2. Now remember, 3/2 is just 1 1/2. Now his yard is on the left side of the fence because he lives where x is less than 1. Does he own the fence? Nope, because he does not have the or equal part. So let's graph him. The y-intercept is 3/2 or 1 1/2. Now here is where people mess up. People want to go on the fence up to 1 1/2, but the fence is not on the y-axis. So you're going to go on the y-axis up to 1 1/2. Now the slope is 1/2, which is up 1, right 2. But if I go up 1 and right 2, I'm not in Mr. Red's yard. So I can't go over there. Remember, Mr. Red lives here. So instead of going up 2 and right 1, I'm going to have to go the other way, down 2 and left 1. So down 1 and left 2. I said it backwards. Down 1 and left 2. Down 1 and left 2. Down 1 and left 2. And I'm going to erase this one. Now, I'm going to draw this picture, but here's the deal. He lives all the way up to the fence, but not including the fence. So here's how I'm going to draw this. And I'm going to go this way just until he runs into the fence. And I'm going to put an open circle because he does not own the fence. That's how that's going to look. Now let's draw Mr. Green. Now Mr. Green lives here where x is bigger than 1. And he owns the fence because he's got the equal 1. So his house looks like that, -x + 3. Y-intercept is 3. Now remember, you go on the y-intercept, not on the fence, because the fence is not on the y-axis. So I'm going to go up to 1, 2, 3. Uh-oh, I'm not in the right yard. I'll erase that in a minute, okay? I have a slope of -1. So a slope of -1, down 1, right 1. Wait a minute. Does that, where Mr. Green hits the fence, is that where that open circle is? Well, let's think about that for just a minute. Remember here, X is 1, okay, on the fence, X is 1. Now, for Mr. Red, where does he run into the fence? Well, here's what I'm going to do. I'm going to let X equal 1, and I'm going to see exactly what that Y value is where he runs into the fence. Notice all I'm doing here is I'm letting X equal 1. Well, half of 1 is a half. Whoops, I'm getting where you can't see, right? So that's 1/2 plus 3/2 is 4/2, which is 2. So Mr. Red runs into the fence when Y is 2. Well, where does Mr. Green touch that fence? Well, let me erase some of this because that's getting hard to see, isn't it? Here, when X is 1, the opposite of 1 is -1 plus 3 is 2. Now look, he hits the fence, this is Mr. Green, at exactly the same place where Mr. Red is holding on to the fence. So guess what that does? That fills in the hole. And then I'm going to finish. Down 1, right 1, down 1, right 1, down 1, right 1. That's what it looks like. Now I want you to be, oops, and I need to erase him over there. He is trespassing. Now I want you to be careful about one thing. What I'm looking at is this spot right there, where I should have drawn Mr. Green in green, shouldn't I? I drew him in blue. Oh well, we'll call him Mr. Blue. I do not want you right there to draw an open circle and then draw a dot in it. That's not how it works. If you have an open circle for one graph and it gets filled in by another graph, then it's just a filled in circle because somebody owns that spot. So you make sure that that spot, let's see if I can do this well. The open circle you had now is filled in, okay? Make sure you fill that in. All right, now we have one more to look at. And this one has 4 pieces, have mercy. 4 pieces. Guess what that means? We've got 4 fences. Actually, we've got more than 4 fences. I want you to look right here. Whoops, I didn't catch it all. Right here. Every one of those X values is going to be a fence. Have mercy. All right, so I'm going to have a fence at X equal 1. I'm going to have a fence at X equal 3. I'm going to have a fence, there's the 3, I've already done that one, at X equal 4. I'm going to have a fence at X equal 5. 1, 2, 3, 4, 5. Goodness. These yards are going to be very, very narrow, aren't they? At X equals 6. At X equal 8. I sure hope I've got that in the right place. I'm going to have to count. 1, 2, 3, 4, 5, 6, 7, 8. Yep. And then at X equal 10. Woo-wee. Okay. Now, before we go anywhere else, I want to remind you about if you have the equation f of x equals 0. You see there's no x over here. This is another name for y. So this is really just y equals 0. When you have y equals a number, that is just a horizontal line. Since none of these pieces have an x value, what you're going to have is 1, 2, 3, 4 horizontal lines in this graph. Now here's the deal though. We've got more than 4 yards. we've got a yard here. We've got a yard right here. We've got a little yard right here, a little yard right here, right here, right here, right here, and then here. So the question is, who lives in each of those yards? Let's start with this one right here. Who lives where x is less than 1? There is not a place here, there is not a constraint that says x is less than 1. So guess what? Nobody lives there. There is not going to be anybody who lives in that section. That's just a park. It's government property. So let's just say that's a park. Now, who lives right here? Well, that's between 1 and 3. Oh, there's between 1 and 3. So y equals 0 lives there. Does that make sense? Let me erase this up here so I can write this stuff in better. So right here, y equals 0 lives. Now, who lives right here? Well, that's between what? 1, 2, 3, between 3 and 4. Who lives between 3 and 4? 2 does. So 2 is going to be there. Who lives between 1, 2, 3, 4? Who lives between 4 and 5? There's nobody between 4 and 5 because the next yard goes from 5 to 6. So nobody lives between 4 and 5. No one. No one lives between 4 and 5. Okay, so I'm just going to erase the green. Nobody lives there. Let me see. 1, 2, 3, 4, 5. Okay, so I'm on this piece right there now. That's between 5 and 6. Who lives between 5 and 6? Well, 5 does. 5 lives there. Who lives between 6 and 8, which is this piece right here? Nobody lives between 6 and 8. There is not a piece that says between 6 and 8. Nobody lives there. Nobody. So let's go between 8 and 10. Who lives there? Well, 9 lives there. So the number 9 lives between 8 and 10. Now, who lives out here? Well, the constraints don't go past 10. There's nothing that says x is bigger than 10. So nobody lives out here either. So let's start drawing our horizontal lines, but the issue is going to be who owns the fences. Let's start with, let's start with 0. Does 0 own the fence on his left or the fence on his right? Or both? He might own both of them, and he might not own either one. Well, he owns the fence at 1, but he does not own the fence at 3. So y equals 0 is going to look like this. He owns the fence at 1, so we have a solid point there. Horizontal line ends at 3, but he does not own 3. Now, we're going to 2. Well, does 2 own any fences? Well, 2 owns the fence at 3, but 2 does not own the fence at 4. So we're going to y equal 2. Y equal 2 owns the fence at 3, but he does not own the fence at 4. Now, let's change colors. 5. Now remember, he's between 5 and 6, so we have this gap between 4 and 5 where there's nothing there. That's a little bitty teeny weeny park. 5 owns the fence at 5, but does not own the fence at 6. So we're going up to 5. 1, 2, 3, 4, 5. He owns the fence at 5, but does not own the fence at 6. Now remember, in this next chunk, nobody owned that either. So that's another park. Now let's go to 9. Does 9 own any fences? Yeah, 9 owns the fence there at 8, and 9 owns the fence there at 10. So we're going up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 owns the fence at 8, and 9 owns the fence at 10. Nobody lives past x equal 10. So there's your graph. Now that is just little bitty horizontal pieces, right? This is an example of something called a step function. Now we could get into a whole lot of stuff. There are all kinds of application problems in the real world about step functions. We're not going to get into that right now. But just please trust me when I tell you that there are lots of examples of real life stuff with step functions, especially in pricing, like with the post office, or how much you pay for your water or your electricity, stuff like that. And that is what I have to teach you about graphing a piecewise function. I forgot. Don't hate me. I have one more. Sorry. Forgot. D. Now I got to write this one in. I am so sorry. Got y'all excited about being finished and I forgot. Let's look at this one. X plus 4. Oops. Oh, I'm going to do it like this. And 2x plus 5. And negative x plus 3. You notice I didn't put the word if or the word for in there. You don't have to. As long as you have a comma in between your equation and your constraint, you don't have to put a word. Those words if or for are just assumed. Okay, so let's talk about our fences. Well, I'm going to have a fence here at x equal negative 4. I'm going to have a fence. Remember, I'm looking for every x value I've got. Negative 4, 1, and that's it. So I'm just going to have 2 fences. So I'm going to draw a fence at x equal negative 4. 1, 2, 3, 4. So I'm going to draw a fence right here. And I'm going to draw a fence at x equal 1. Now let's decide who lives where. Well, this is Mr. Red. And Mr. Red lives in the yard where x is less than 4, or excuse me, x is less than negative 4. So Mr. Red lives over here because this is the area that has x values less than negative 4. Now Mr. Green lives between negative 4 and 1. So Mr. Green is going to live in this section. And then Mr. Blue lives where x is greater than 1. So Mr. Blue is going to live over here. We'll deal with the fences in just a minute. So let's draw Mr. Red's house. Well, Mr. Red's house is x plus 4. That's a y-intercept of 4 and a slope of 1. So I'm going to do a y-intercept of 4. Now remember, it's not going to go on a fence because the fence is not on the y-axis. So you're going to go y-intercept of 4. Oh, he's Mr. Red. 1, 2, 3, 4. Now you're thinking, uh-oh, he's in Mr. Green's yard, he's trespassing. He is, but let's get his house drawn and then we'll go back and erase our footprints so we can pretend we weren't there. We have a slope of 1 because there's a 1 sitting right there. Remember, a slope of 1 means up 1, right 1. And if we go up 1, right 1, we're going to end up in Mr. Blue's yard. So instead of going up 1, right 1, we're going to go left 1 and down 1. I'm still in Mr. Green's yard, but at least I'm getting closer to my own yard. Now the next point I would draw would end up on the fence. Does Mr. Red own the fence? No. So you're going to draw an open circle right there and then continue. Here's Mr. Whoops. Oh, snap. That's not what I meant to do. So here's Mr. Red. And remember, we got to go back and erase our footprints from Mr. Green's yard so he doesn't know we were there. Okay, Mr. Green. Mr. Green's house is 2x plus 5. Y-intercept is 5. 1, 2, 3, 4, 5. Now remember, that's okay. The y-intercept is in his yard, so I can be there. Slope is 2, up 2, right 1. Now up 2, right 1 lands him on the fence right here. Does he own that fence at x equal 1? Yep. So that's good. We're going to stop right there. Now remember, I can't go any farther to the right because I get in Mr. Blue's yard. So instead of going up 2, right 1, I'm going to go down 2, left 1, 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 which is going to put me on that fence. Does Mr. Green own that fence? Well, dadgum, he owns both fences. Right there. So this is Mr. Green. Right there. Now let's graph Mr. Blue. Well, Mr. Blue has a nice big yard. His y-intercept is 3. Now remember, if I go to 3, I'm in Mr. Green's yard. This is going to help me get the house built, but then I got to go and erase my footprints. Slope is -1. Down 1, right 1. Now that ends up on the fence. Does Mr. Blue own that fence? Nope, Mr. Green does. So that cannot, let me get a tiny eraser right there. That was tiny, wasn't it? It's going to be an open circle, and then down 1, right 1, down 1, right 1, and there is Mr. Blue. But I got to go back and erase. Let's see if I can get in there and erase that one. And that, ladies and gentlemen, is another example of graphing a piecewise. Now I'm finished.